Hello everyone, today's circuit is this thing right here. This is a pretty simple circuit at first, but it's actually really complicated. So, first of all, you have the 5-volt input right here, this one, through the resistors to the LEDs. So, both LEDs turn on, because the current is flowing through the LEDs because it has nowhere to flow. But shortly after you turn it on, like nanoseconds, the transistor turns on, this transistor right here, and current doesn't flow through the LED, it flows through the transistor. It also flows through the LED, but it's less, because it has a higher resistance than a transistor. It has a pretty high resistance compared to the transistor. Transistor acts like a short circuit. It doesn't draw that much current because it's a 1 kilo ohm resistor right here. All the resistors are 1 kilo ohm, so it goes all to the transistor. The LED remains with no current. And then this also charges up this capacitor. Charging up this capacitor turns off this transistor, allowing current to flow again through the LED, and turns on this LED, the other LED, sided, and then this is the negative. Now I'm gonna put on the 5 volts, and if I turn my lights off, that's pretty cool. Always 10x your scope, and my lights are back on. When I wanna probe across something, I get the other scope head. I'm back and I'm plugging the... Now we have everything all ready for scoping. And first of all, let's scope the base of the transistor. On and off voltage, I need a higher time. So, when we probe this, we see a capacitor charging and discharging. But why don't we probe directly a capacitor? Probing the capacitor, this is the other part of the capacitor. So it's charging and discharging. Turning off and on the transistors really quick. The higher the capacitor value and the higher the resistance, the faster it charges. And that allows current to flow through the LEDs. Current is still flowing here, but not through the LEDs. See? It's still flowing, but not through the LEDs. Let's now short something, and you see the capacitor charge value. Now once again, this explains the simulation I did earlier. This is a pretty cool circuit with complex design. It's also quite complicated. You could probably make a 555 timer simpler than that. I think you could, because that has like 2 resistors, 1 capacitor, and no transistors except for the chip itself. I'd say it's a medium level project, but it looks pretty nice. You can't deny that, it's pretty nice. This was about it for today's video. See you next time.